All right, chapter 9-1, obviously we're starting a brand new chapter and it's over some brand new information. So today is powers and exponents, and I think you guys are very familiar with this. So this should be a nice, quick little review for you, okay? As a little review here, when you have a number, we call that the base. And then the number that's written up above it a little bit smaller and toward the top is called the exponent. Okay, and you think about in cheerleading, you've got the basemen that, you know, hold up the cheerleaders. So that's base, right? That base is what holds up the exponent. And exponents and powers, it's all about multiplication. And so what it means is it's the base times itself, however many times the exponent tells you. So 2 to the second power means 2 times 2, which equals 4. Okay. If we have, I really shouldn't have used 2 to the 2 because it's kind of a unique one. It's the same either way, but let's look at 3 to the third power. Okay. 3 to the third power means 3 times 3 times 3, right? The base times itself 3 times, which equals 27. And the most common error in exponents is everybody wants to say 3 to the third power is 9. Right? They want to take 3 times 3. Or 3 to the fourth power, right? Would be 3 times 3 times 3 times 3, which equals 81. Everybody wants to say 3 to the fourth power is 12 because 3 times 4 is 12. So really try to get that out of your head. And if it helps you, and if you need to, bust it out like this, right? This is the expanded version. This is the kind of the shorthand version, and they both equal 81. So it doesn't matter which way you write it. So if it helps you to not make that common error, then break it out into its expanded form to work it. Okay. Also, sometimes when you're figuring out signs, sometimes breaking it out, and I'll show you here in a minute, but breaking it out in its expanded form will help you if you've got like a negative that you're taking to a certain power. Okay. But that's jumping ahead of it. So very, very quick review on what exponents look like and the terminology that I'll be using a lot because I use base and exponent or power. Power and exponent are kind of interchangeable. All right, so the first half of your assignment is going to look just like this as far as instructions, and always read your instructions, okay? It's going to tell you what each section wants you to do. This first section is very, very simple. We are writing the expressions using exponents. That is it. We're not solving, evaluating. We're not figuring out what 11 to the third power is. We're not anything like that. We're just simply taking it from the expanded form of 11 times 11 times 11, and we are writing it in the exponential form, meaning we're going to write the base, okay, the base of 11. We're going to keep the base of 11. And we're going to write it as an exponent, and 11 times 11 times 11 is the same as 11 to the third power, or 3 11s times itself. That's pretty much the top half. Okay, I'll do a couple of other examples just to show you different ways you might see it, but it doesn't get any harder than that. How would I write this one with a power? I have to have a power because it says right here, I got to have an exponent. Miles? Yeah, really every whole number has a 1, but mathematicians are lazy and we never write it. Kind of like every exponent has a 1 out front, not exponent. Every variable has an exponent out front. Okay, I quit. That's it. We're done. No, I was teasing. Every variable has a 1 behind it, right? That we never write, but it's there. Every whole number has a 1 under it as a fraction. We never write that. Well, every whole number and every variable also has an exponent of 1. We just never write it. So could you imagine if we wanted to write the number 5 and every time we did, or we had to write 5 over 1 to the first power? We just don't ever write them. They're always there. Okay. We can use them in different ways for math, and we will later on, but in everyday writing, we just don't write them. Okay. All right. I've got some notes here of specific ones I want to do on here that are going to match ones on your homework. So let's do number 4 here. Okay. Everybody wants to put equal 16, which is true, but that is not what the instructions tell you to do. You're just going to simply take the base right? It matches. So your base stays your base. And then how many of them are there? There's 2. So that is writing this expression with exponents. Okay, we're not solving it or evaluating it. I don't need to know that it equals 16. It does, but I don't need to know that just yet. Okay. And the reason I picked this one is to show you that the black dots mean multiplying. The touching parentheses mean multiplying. Sometimes you'll see it, well, not on here, but sometimes you'll see it like XZ. Okay, that is also 2 variables touching, means multiplication, right? So you might see it 3XZ. That's still all multiplication. Numbers touching variables, touching variables. It's the same as writing it like this. It's the same as writing it like this. Okay, and we don't ever see this, but it's even the same as writing it like that. All of that, these right here, they all mean the same thing. Okay, all means multiplication. And powers, it's all about multiplication. All right, so number 8 here looks a little wonky because it's a little bit of a mix between parentheses and the black dot for multiplication. But does a parenthesis touching a parenthesis mean a black dot? We're good there? Another parenthesis touching a parenthesis mean a black dot? So really, this is just B times B times B times B times B times B, which is B, because that's your base, right? To the what power? How many do we got? 6. Oh, I thought I saw somebody hold it up in their fingers. 6, yes. B to the 6th power, okay, is the simplest way to write that using exponents. Uh-oh. All right. The next one I want to do is number 9. And you don't even have to put this in your notes if you had number 4 up in your notes because it's really the same. But again, everybody wants to try to evaluate this and multiply all those negatives. Don't, okay? I don't care what the actual answer is. All I want you to do is write it in exponential form. So notice your base all along here. It's all the same, right? And then how many do we have? Lincoln, how many do we have? 4. There you go. That's writing it in exponential form. Okay, very basic. All right, how about when we have, let's look at number 12 here. What if we have a bunch of different bases? Okay, give you a second to get that written down. M times M times M times N times P times P. Take it one base at a time. I've got some M's here. So I'm going to have in my answer M to the what power? Anybody? Anybody, just say it. 3rd, good. Next, I go to my next base, which is an N. What's my power here? Caden, 1, good. I go to my next base, it's P. How many of those do I have? 2. That's your answer. Just simplifying it up and writing it all with exponents. Okay, how about if we have number 14, numbers and variables together? Does it change anything? Nope. Start with your first base, which here is 3. Okay, how many do I have? 4. Go to your next one, P. Only got one of those, so I'm going to put a 1. Don't forget the 1. Okay, it's important. They all have an exponent because that's what the directions say to do. And then go to your Q's. How many do I have? 3. And that's writing that in exponential form. Okay, that's the top half of your assignment. I wanted to do enough examples that you kind of had a good mix to represent every kind that you're going to have on your homework. Now I want to jump down to the bottom. Doesn't get any harder. If you don't know, you need to write down PEMDAS because your order here is going to matter. You're always going to deal with parentheses first, then exponents, then multiplication, then division, addition, subtraction. Okay. So PEMDAS matters. You got to follow it when you're evaluating. We got to look at our instructions here. They change a little bit. Now we're evaluating, right? Now we're doing a little bit of math and we're doing it with each expression and it gives us some specific information here. It tells us that X equals 3 tells us that y equals -2 and z equals 4. Write that in your notes because your notes won't make any sense if you don't have this little legend up here. X equals 3, y equals -2, and z equals 4. And we're going to keep PEMDAS in mind. So if we look at number 15 here, it says y, which is the base, raised to the z power. Well, y is -2. Right? Y is -2 raised to the z power, or the exponent here would be the power of z. And in this case, z is 4. And now it actually asks me to evaluate it, not just leave it in exponential form, but what does that actually equal? Well, if it helps you, expand it out. -2 times -2 times -2 times -2. Well, -2 times -2 is +4. I can do it again. -2 times -2 is +4. And if I multiply those together, I get 16. Okay. Notice that when I multiplied 4 negative numbers together, I got a positive answer because a negative times a negative would be positive, times a third negative would go back negative, and then times a fourth negative would go back positive. Okay, so I've got a little memory. I've got a little memory trick here just to kind of help a little bit. And that is that if your base is negative, okay, this is only if your base is negative. If you have even exponents, your answer is going to be positive. And if you have an odd exponent, your answer is going to be negative. And I'll show you why. I'll show you an example here. So we already took -2 to the 4th power and we got a positive 16, right? What if we take -2 to the 3rd power? Why would it be negative? Well, let's break this out. -2 times -2 times -2, right? -2 times -2 is +4. And then we have to multiply that times that remaining -2. And 4 times -2 is -8. So if your exponent is odd and your base is negative, your answer is going to be negative. If your exponent's even, it's always going to flip back to 2 negatives equal a positive. Okay. All right. So just a real quick reminder. I think you guys should know this, but just in case, what is anything to the 0 power? It doesn't matter how big or little the number is. 1. Perfect. Don't have to do any math there. Anything to the 0 power is 1. Yes. Oh, it could be the number 2. It could be 1/2. It can be 1 trillion bazillion. If it's to the 0 power, it equals 1. Okay. All right. How about when we have one like number 22? Z squared times 2 squared. Z squared times 2 squared. Well, first of all, what does Z equal? What was it? 4? Okay. So I'm going to fill this in here. Z is 4 times 2 squared. Now, PEMDAS says parentheses first, don't have any. Next exponents. Don't multiply 4 times 2 here. You've got to do the exponents first. 4 squared is 4 times 4, which is 16. 2 squared is 2 times 2, which is 4. And now multiply 16 times 4, which is 64. Okay. You have to do your powers first. You got to follow PEMDAS. Okay. You got to do your exponents before you do multiplication. All right. Last example, and it's not on here, but I wrote it because I want to do it here, is what if we have, and I'm just going to make up a problem here. What if we have 6 squared minus 3 all to the 2nd power? All right, PEMDAS says parentheses first. That means I'm going to work just inside here first. Okay, so just inside my parentheses, what is 6 squared? 36 minus 3. Okay, I still have some work to do inside my parentheses. It's not a single number yet, so I'm going to stay working inside my parentheses. I'm not going to worry about that 2 out to the side. Just inside my parentheses, 36 minus 3 is 33. Now all I have left is that power. I'm going to go ahead and take 33 to the 2nd power. Anybody know what that is off the top of their head? I sure don't. It is 1,089. Okay, if you try to do this out here first and you try to square something, it's not going to work. Always work inside your parentheses. Get that down to where it's just a single number, then apply any power that might be outside. All right. And I think that's it. That is everything. I've done a little bit of everything that you're going to see here. I don't think you even have one like this on your homework. Nope. So I'm not going to worry about doing it. Okay. You don't even have one like this on your homework. All right. So again, your homework for tonight is 9-1. Okay. If you're at home, you're going to do the Cami version of that. And then just keep watching Canvas for updated information as far as weather related assignments and what you need to do each day to stay caught up. Email me if you have any questions.